This episode is supported by Primal Technologies. Primal offers secure and cost-effective data privacy solutions for your organization. It generates a synthetic alternative without disclosing your confidential data. Check it out at primal.io, pryml.io.
Thank you for listening to Data Science at Home podcast with Francesco Gadaletta. You are about to get cutting-edge insights from the people who are reshaping the world of technology with machine learning, data science, and artificial intelligence. It's time for Data Science at Home. Welcome to the show.
Welcome back to another episode of Data Science at Home podcast. I'm Francesco, podcasting from the regular office of Leuven in Belgium. We are at the next episode of series Rust in Machine Learning. And today I'm not alone. I am with Mr. Alec Mocatta. Hey Alec, how are you doing?
Hello. Thank you very much for having me.
Yeah, it's a pleasure to have you here. And Alec is a programmer. Can I say that, Alec?
Yeah, that is what I call myself. Yes.
Cool. Well, he has spent quite some time between data science and distributed computing, so I'm pretty sure that the audience of Data Science at Home podcast will enjoy you speaking today.
Well, thank you very much.
So, Alec, what's your background? Introduce yourself, please.
So, as you said, I'm a programmer by background. I've been programming for about 20 years now. I've recently started and sold a couple of companies. The first one was in the space of data science. The second one was more focused on distributed computing. And those are sort of my two primary areas of interest.
Nice. And so you have been close enough to the Rust programming language. So my question is, how did you get close to Rust? Like, what triggered you?
I think it was seeing it at the top of Hacker News. On a very regular basis. I would click through and it seemed people were saying all of the right things about it. People were saying the fact that it gave you control, but it still was it let you build powerful abstractions. That was really interesting to me. I'd come primarily from C and C++, with also some Python, some JavaScript, and a bunch of others. But I always liked having that control of C++. Of C and C++, but I like the idea of something that was a bit more powerful, where I could be more productive as I was in, say, Python. And I tried Rust, and there is a bit of a learning curve. It really takes time before you're productive, but when you've mastered it, I saw fairly quickly that I was more productive than I was in pretty much any other language, including Python and JavaScript. At its best. In Rust, at its best, I felt I was more productive. At its worst, I felt I was maybe sort of 10 times less productive, because occasionally you do bump into things that are just quite tricky in Rust that you find straightforward in Python. But those, as time goes on, are getting fewer and far between.
I had a very similar experience when I decided to add Rust to my arsenal. And indeed, the learning curve was quite steep at the beginning, though for from C, probably that gap is partially filled. Now, I've been spending some of my time lately trying, finding machine learning related projects in Rust. And to be honest with you, I didn't expect to find that many. But I found some that are really, really interesting. And to the audience of this episode, of course, I got to know Alec due to a project that was on GitHub, silently committed. The project was under the name of Amadeus. Did I pronounce it correctly, Alec?
I believe so.
Sounds Latin, Italian, I don't know. Well, so Alec is the author of the Amadeus project. So Alec, what is Amadeus and what problem does it solve?
So Amadeus is what I've wanted to do large-scale data science. I've tried some other tools. I've tried tools like Spark, and I found them to be quite cumbersome, a bit of a sledgehammer to crack a nut, and not ideal. There's this huge learning curve, and then they get in the way. They cause all kinds of other problems when you're just trying to do data science. And I'm, as I said, primarily a programmer, so I thought we can do better than these. So with Amadeus, what I wanted to do was find a way to let people write their data science computation in idiomatic Rust, in straightforward idiomatic Rust, in a way with almost no learning curve. So use the same primitives that they're used to. So in Rust, there are these things called iterators, and they're super powerful. And then once you kind of learn how to use them, you can use them. They're very widely applicable. I wanted to work out how to adapt this to data processing, and specifically parallel data processing. And then also I've been working on enabling it to be distributed, so that you can compose your data science pipeline and you can run it locally, you can iterate locally. But moving into production on a cluster is then basically just flipping a switch, and Amadeus will run your computation in parallel across arbitrarily many machines. And Amadeus makes some design choices to make that possible. I think we'll probably get onto them. Amadeus has limitations, but because of those limitations, it is able to kind of do the job so neatly and without issue.
Now, if I were a data scientist in front of you, I would be asking, how different is Amadeus from, for example, Dusk? Dusk, for the record, is a lighter version of Spark that allows you to create transform your algorithm or your code, parallelizable code, into a computational graph, and then lazily compute the graph once you trigger the compute button, let's say. So how far are we from that paradigm of computation? And what are the major differences that you envision between Amadeus and Dusk?
So under the hood, they're pretty similar. Obviously, Dusk has a Python interface, and it's obviously quite dynamic. Amadeus has a Rust interface, and that's more statically typed. The key that there are limitations that I mentioned that Amadeus has that Dusk doesn't. Amadeus does not give you something like a data frame to work with, and it does not let you, for example, sort a data set, or even do things if the data is unordered. If you've got two large data sets, it won't let you join them, for example. Whereas Dusk, I believe, does, and that is due to the limitation that is in Amadeus, which is that it focuses on streaming computation. So computation that only has in memory at one time a bounded number of rows or elements. And that, when I've seen large scale big data deployments on Spark or Custom or whatever else, that's all of them fall into this category of streaming. Because more complex operations like large-scale distributed joins are not a solved problem, and actually no one is doing those reliably in production at large scale. But streaming is a solved problem. It just hasn't been done in Rust, and so that's where Amadeus comes in.
Wow, so you're definitely filling a gap there. Now, in one of our chats, because Alec and I have spent quite some time on different channels discussing about Amadeus and some, I'm not saying a vision of Amadeus, but definitely what a data scientist could be enjoying about this framework. There was once a problem that you put to my attention, which is a very interesting one, and it's quite fundamental. Which is the problem of out-of-memory errors. So can you describe what this problem is about, and how does Amadeus solve it?
Sure. So what I've seen with large scale, I mean, I've seen Spark. I actually haven't seen large scale DAX deployments, but I've seen large scale Spark deployments. And what I've seen in them is a long process of like the most part of a year trying to scale up what they were doing at small scale. And this process scaling up, they tend to be doing things like joining two large data sets, or doing, or more commonly, doing something akin to a group by operation. And at at scale, you almost inevitably eventually run into issues with running out of memory on a partition. This seems to happen again and again, and you end up in this iteration cycle of trying to kind of refine your data, so clean out any sort of bogus data that could cause partitions to overflow, and simplifying your algorithm just to try and get it to run. And essentially, what people end up settling on is doing it ultimately in almost a streaming manner. So, if you're running at scale, the operations that involve shuffling, they tend to be too painful in production. So people tend to move towards streaming, because that still solves a lot of problems. This is where that limitation of Amadeus comes in. As I said, it focuses on streaming, so where the number of rows or elements that are being processed at one time, that are in memory at one time, is bounded, and this avoids those out of memory errors. This avoids partitions overflowing, because the partitions here are a fixed size; they're bounded. So you can run it arbitrary, no matter what scale you want. You can run over tens of thousands of computers. You're not going to run out of memory, because you know how much is being used on each partition.
So, out of curiosity, Alec, how do you define this minimum or maximum number of records that you would send, or you would bind that partition?
So this is essentially, this number is what the concurrency is, how many being processed at the same time, and this is the sort of one configuration option that Amadeus has. In the sort of hello world examples that are in the README, this is probably the main difference from normal idiomatic Rust iterators that I mentioned earlier. You specify, first of all, if you're running distributed, you specify the number of processes it should use, and then you specify the number of tasks it should run concurrently. And both of these are optional. If you don't pass either of these values, it'll use as many processes as are available, and it'll use a sane default for the number of tasks to have at one time.
Got it. Okay, nice. And so let's assume I'm a data scientist that would like to use this framework. I know it's not ready, it's just a hypothetical question. So what type of data can I connect to Amadeus as we speak?
So I've been working to add some more data formats that it understands, but so far Parquet, Postgres, CSV, JSON, and then some more sort of specialized formats. One that I was using for myself was taking the logs from CloudFront from an S3 bucket. That's what it's got so far, and there are a couple others I'm working on, and those as well. They all work from local hard drive, all from S3. So if you've got data in an S3 bucket stored in Parquet or whatever, then you can point it to that and it'll just work.
Interesting. Well, it's a decent list that definitely covers, I would say, 80% of the data science workflows that I've seen so far, if not more. All right, so let's switch gears and speak about distributed computing. What do you think?
That is a big question.
It is. So let me be a bit more specific here. So when we talk about distributed computing, of course, we require some sort of stack or framework that allows machines to cooperate to a particular computation, right? So this is a very general explanation or definition of distributed computing. Now, is it possible for multiple machines and not just local cores to collaborate to a computation in Amadeus?
That's essentially what's happening. I mean, so Amadeus is built on this library that I wrote called Constellation, and that is, and the goal of that is to make programming multiple machines as easy as programming multiple threads. So the way that you program multiple, the typical way that in Rust you program multiple threads is by there's sort of one function to spawn a thread and run a function on that thread, and then you have channels, and a channel has a sender and a receiver, and you give some data to the sender and it comes out of the receiver, and you can have one end on one thread and the other end on another thread, and so that is how threads can communicate. Now, there's no reason why you can't have those same two primitives of essentially being able to spawn a closure and communicate across channels between threads. There's no reason why you can't have that between processes that are running on different machines. So that's exactly what Constellation aims to do. It aims to make it, I mean, essentially make, in the same way threads are kind of tightly coupled, this aims to make processes across multiple machines tightly coupled. So you have essentially one program that is just happens to run on a bunch of machines. And you program it just the same way. I mean, exactly the same way as you do with multiple threads in Rust.
Except that you have a distributed cluster behind your computation, which is impressive.
Yeah. As it happens, I mean, this is entirely transparent to the user.
Nice. But
they're communicating between what happens to be multiple processes, and sometimes these processes will be on the same machine, but oftentimes they'll be on a remote machine, and this is transparent to the user.
This is super cool. I mean, once this is ready, I definitely believe that a much larger community would hang around this, because I mean, this in fact spares people a lot of time and hides a lot of complexity, behind distributed computing, so that people can in fact focus on their business application or the particular use case or their machine learning algorithm, and forget about the way this algorithm is distributed, which is, I mean, I think the ultimate goal of all these frameworks that try to save time to the poor data scientists out there. Now, speaking about the community, I have definitely a let's say a philosophical question for you. I mean, I know that Rust. We all know that Rust is a pretty young language, a bit more than 8 years, if I'm not wrong. And of course, there are libraries in Python that is, the de facto standard for machine learning and AI applications today. But of course, it has been around for much longer. Now, my question is, what do you think it's missing for Rust or for the Rust community to be adopted, let's say, en masse by the machine learning and AI community?
I think the biggest hurdle is the ecosystem. Rust is a very relatively new language, and the ecosystem is growing. I mean, it's the chart of crates, what Rust calls packages, is growing rapidly. But it's still, the ecosystem is unfortunately still a way behind something like Python for data science. But it is making improvements, especially as we're seeing more and more large companies make a big bet on Rust. I think, every large tech company now has significant portions of their infrastructure built in Rust. It's only a matter of time before more and more of their data infrastructure is built on Rust. And as that happens, as people who are building that stuff, they move on and they think this worked really well inside X large company. I'm going to try and create an open source version of that. I think we're going to see more of that. And I think we're going to start to see more of the sort of underlying infrastructure side move to Rust. I think for a long time, there'll be room for Python bindings on top. And again, that's something that is only becoming really nice relatively recently in Rust's history. There's this Rust project called Pio3, or maybe its name's supposed to be pronounced differently, but it makes it unbelievably easy to make really nice Python bindings. So I think there's a lot of kind of ingredients there. I think there's just some time and a lot of effort needs to go into really bringing everything together and getting adoption, and making it sufficiently productive for data scientists and data engineers to justify picking it up and using it for their data.
Yeah, I totally agree with you. I mean, I really wish that Python becomes the let's say the front end language, and so every language should be at its own place. So I strongly believe that Rust is I believe that Rust is more than just systems programming. It could definitely play a nice role in many backend systems. I've been discussing this in another episode of the same series, Rust and ML on Data Science at Home. But okay, I mean this is a nice vision, and I also embrace that. So of course the community is young. Now, speaking about the community, feel free to join the project of Alec. A bit of PR here, Alec. Allow me to do that.
Well, thank you very much. And feel free to, as Francesco did, drop by the chat and say hi.
Yeah, I mean, I think the Amadeus is a great project, and it deserves a bit more attention from the community. And I'm pretty sure that all these frameworks that are, created every day in the Crate.io and somewhere else, GitHub as well, of course. I really believe that is the wisdom of the crowd that will make the difference here. And so let's make a call to the community and to be more active in developing these new tools or existing tools in this new amazing language. Alec, it was nice to have you here on the show. I'm pretty sure that the audience of Data Science at Home podcast appreciate your presence here and your pearls of wisdom. I also have the pleasure to announce that Alec will be speaking at the LDN Virtual Talks on June 24th, 2020. I will report the link on the show notes of this episode on datascienceathome.com. As I was saying, Alec will be speaking about data processing in idiomatic Rust. He will introduce Amadeus as the open source library for fast and reliable data processing and analysis in Rust. And in the talk online, it will, of course, provide an example of how to process data from a Parquet source and other sources. But of course, I will not disclose more. I'll talk to you next time. Thanks.
Thank you very much.
This episode is supported by Primal Technologies. Primal offers secure and cost-effective data privacy solutions for your organization. It generates a synthetic alternative without disclosing your confidential data. Check it out at primal.io. pryml.io.
You've been listening to Data Science at Home podcast. Be sure to subscribe on iTunes, Stitcher, or Podbean to get new fresh episodes. For more, please follow us on Instagram, Twitter, and Facebook, or visit our website at datascienceathome.com.